Hello everyone. So recently I played the game Portal, which is a very famous game. I'm pretty sure you all know that. So I thought of implementing this portal effect in Unreal Engine. So this is what happens in the game. We can shoot at walls, certain type of walls, and on those places a portal appears, and from this blue portal, when we enter from the blue portal, we exit from that orange portal. So that's the basic gameplay mechanism we have here regarding the portals. So that's what I'm going to implement. So in this episode, we are going to implement that portal effect. Not everything, just this how to show from one portal what we would see from another portal. So this is the blue portal, and I have placed another orange portal here. So from this portal I see what I would see from the other one, and as we move around, you see the view also adjusts just like we would be seeing from the other one. So here you can see these three boxes. These three boxes we can see from here. See? So yeah, let's see how to implement this effect today. Later on we will implement all the mechanisms of the portal game, such as how to jump this and how to shoot at walls and create the portals in the locations that we need. But first let's figure out how to do this camera's work. Before we get started with the tutorial, I'd like to remind you that you can download the project files of all of the tutorials that I have done in my channel in the Patreon page. So this is going to be 1637th tutorial today. So for all of those thousands of tutorials, you can download the project files for the membership without a limit. So I'll leave the link in the description below. And let's get back to the tutorial. Alright, so let's start by creating a new project using the first person template. I'll name this CodeLikeMe Portal. Right, so this is what we got from the beginning. So the usual first person template. Now let me create a BP folder. Here I'll create a new blueprint class. I'll name it BP portal. So before we implement, like in the portal game, we can from the portal gun we can shoot at a wall, and in that place the portal appears, and if I right click, another portal appears in another place. But before that part, I'll just implement the portal mechanism, so then later on dynamically change their locations and implement that behavior. Okay, now let me open this blueprint. Now we're gonna need two doors, portal doors. So for each of portal, we're gonna have the door and a scene capture element, a scene capture component, so a couple of things. So therefore I'll create two blank scene components, D1. So this is the root of the first door. I'll keep it here, and D2, the root of second door. I'll move it somewhere like this. Oh, it would be better if the 51 is here. 51 is first. Right, now the portal. So for this I'll add a plane I'll call it door1. It should be facing this way. Let me place this here, and so we can get an idea. Okay, so right, let me rotate it to the other side because player starts here. Place it over here, and as you can see, it's on the ground. Also, I think it would be better if it is a bit larger. So how about 2? Right, and if I go to front, you see it should match with this ground level. So I'll move both D1 and D2 up. Okay, now it's like this. Nice. So we need another door. So duplicate this one with Ctrl D and drag under door 2. These two keep changing, so I'll leave it that like that. And D2 is here, D1 is here. Wait. I'll move the D1 over here and D2 here, like this. Now we need 2 scene capture components for each door, because from this door we should see what it would seem as if player is looking from this side. So like this. So, and when I look at from here, we should see as if player is looking from this side through this window. So therefore, to capture that, we need 2 scene capture components. And so here, scene capture component 2D. I'll call this P. This is door 2, so P2 capture. And copy, paste. This is P1 capture, and it also should be under D1. Right, now it's like this. Now for testing purposes, let me move this to pull back a little bit, and we need a texture target. So let's create, let me create a new folder, and move it here. Now I'll create under texture one render target. I'll call this P1 RT P1 render target for portal 1, and duplicate this RT P2. Wait. So here in the settings, this is by default size X256, so I'll make it 1K and save and duplicate. Now we have the settings, so we can assign RTP1 to this and RTP2 to the P2 capture. Okay, now we need to create a material to apply to these planes so that we would render what we see through these scene capture components on these planes. So RTP1, let's create material. I'll call it M portal. So as you can see here, let me convert this to a parameter. I'll call it RT, stands for render texture, and I'll convert this to unlit one and connect this to emissive color. Right, apply. Now create another instance from this I'll call it MI portal D2. This is for the second portal. Now here, instead of this render texture, I'll assign RTP2. Okay, now this one contains first render texture, this one contains second render texture. So first render texture should be rendered on the second row, so assign it here, and the second render texture should be rendered on the first row, so assign it here. Now if I compile and play, it's rotated, but we can fix it. Rotate 90 degrees. Okay, compile. It should be correct. Yeah. Yes. Now as you can see, even though I move, it just looks like a static image. That's because we are not moving these capture components as the player moves. Once we do that, this will look like an actual portal. But before that, I need to get this iconic portal shape. So let me open Photoshop. Okay, so here I have created a circle with this outline in red, and I'll make the fill-in green because I need a way to distinguish that. 255 0, and the outline fully red. Okay, it's already fully red. Okay, now I'll save this. Let me import the portal texture, T portal. This is how it looks. Let me drag and drop it here. Now I'll convert this to a masked material and connect alpha channel here. So if I change this to a plane, now this is how it looks. Now we need a frame in one color. So for the frame, I'll get the red channel and multiply it by a vector parameter. I'll call this frame color, and I'll make it blue, bit brighter blue, and I'll add it to this and connect to MCU color. Now you get a frame. It's a bit whitish, so in the frame also I can see the details of the texture underneath. So what if let's multiply this first with the green channel, because middle is totally green. So yeah, now it's only blue. Okay, I'll add a little bit of emission too. Okay, apply. Now you see it has a frame, but both frames are blue. But what we can do is convert this. It's already a parameter, so this one, change it to orange. That's the color they are using. Okay, here is the orange one, here is the blue one. Later we can add the effect to make it a little more interesting. Now let's continue with the portal camera. So now as you can see, it just looks like a static image. So let's make this interactive now. So in order to make this correctly work, we need to do two things. First thing is we need to adjust these scene capture components locations based on player location, and also the next thing is based on their location distance from the portal door, we need to adjust their field of view. So let's first look into how to adjust the locations. And first, before anything, let's change the location of the second portal to D2 to this wall. So it makes more sense. And this one, yeah, now you see it's just this wall because that's what it sees from this side. And you may have noticed in Portal game we can only place portals in certain wall types. So I'll delete this one, 31.4. Let me copy this scale. I'll delete this one and add a plane here. Like this, so that from this side we don't see anything because it's a plane, one-sided plane. Okay, I'm gonna do the same thing to the other wall as well. Before that, let me change the copy, change the material. Right, so this is also a wall. Okay, now first portal, let me move that one also here. Okay, now let's go back here. So we need to calculate the position of these capture components based on player's location. So for that, I'll add some support elements to make our calculations easier. One thing, one under D2 a blank scene component. I'll call it pSim_D2. pSim means player simulator. So this would essentially copy the location, world location of the player, so that we can use it to calculate relative locations. Similarly, let me duplicate that and add another one under pSim_D1, stands for DO1, player simulator DO1. Now I'll create a function update pSims. Update cameras. Wait, did I add scene graph? It should be a function update cameras, and I'll call it in the tick. So note that this, we only need to call this when the portals are active, but for now I'm gonna keep them active by default, so I'll just call it here. But you can disable it when you don't need it. Now we can get player camera manager. So essentially we need to know the location of the camera to match the scene capture component locations, and get world transform. No, there should be another method. Get location. Oh wait, get camera. Oh yeah, this one. Get camera location and get camera rotation. But I don't really think I need rotation. Now basically what I want to do is get these two components, set world location for both of them with the camera location. Now let me explain. Now consider this is the top view and this is portal 1 and this is portal 2. Wait, I can do better. This is portal 1, this is portal 2. P1, P2. Okay, now let's say player is here. This is player is here, and let me get another color. So when player is here, what I'm gonna do is this one has a pSim component. I'm gonna place the pSim component of both doors in this location for both of them, pSim component of this door and pSim component of this one. So that's what happens here. The reason I do that is, so when player look at this window from this location, what we see inside here should look like what player would see from a location like this in this direction through this window. So that's why I have these two components. And similarly, if player is looking at somewhere over here towards at this window, it should look like, let's say player is here. So it should look like player is looking through this window in a location like this. So that's the reason I created these two pSim components. But now from the relative locations of these pSim components, we need to calculate this relative location that player should be in order to look at, in order to see this way. So, and that's the location the capture component we should play. That's the location we should place the capture components of each door. Hope I'm making sense. So basically, the capture component will have the same relative location as these guys, but with 180-degree rotation. So to make that easier, what I can do is I'll put these capture components on another blank scene component. I'll add scene. I'll call it cam root to this one 0 and this 180 because we need to rotate it, and put psimd2 p2 capture under that. Similarly, I'll add another one under door as well, door 1 as well, scene component, cam root 1, location 0, and rotation 180, relative rotation. Put the P1 capture under that. Alright, now here get the P1 capture and also get the, so we should calculate the P1 capture using this psimd2. So what we need to do is set relative location same as get relative location of this psimd2 to simulate the logic that I explained here. Right, and the rotation, well, we need to calculate. Rotation should be from this location, looking at the root of the camera. That means the center of the window. That means get world location of this component and get world location, oh not that, and the parent of this component, get parent, no, get attached parent. The reason I do that is because I can promote this part, this total part, into a macro and reuse the code. So that's why instead of just getting the D2 and getting location, I got the parent, get world location. Okay, now from this location, find look at rotation. So that's world rotation. That's a world rotation. So here, wait. Set world rotation. Okay. Alright, now we need to do the same thing for the other capture component. So let me promote this to a macro, update capture M. Right, now duplicate this and give P2 capture and psim 21. Right. Now if I test, I can go full screen. Here, see? So this looks like we are looking from that window, but as you can see, this looks a bit warped, and also we see down underneath the platform as well. Yeah, especially if I go further. So we need to avoid that. But essentially this is working. Now to avoid this problem, when we are further away, we should not see this part. What we should see is only what we would see from this window. So if we are seeing from through this window, there is no way we are going to see these parts. So to avoid that, what we need to do is, based on the location of the capture component, we need to adjust this field of view. Let me explain that too also with the diagram. Let's say this is one portal, okay, and player is here. This is capture component is here. So now in order to render only the part that we will see through this window, for that we need to have a field of view like this, like this, that encompass only this area. Let's say this is 30. Okay, now let's say player move to a location like this. In that case, we need to adjust, the angle to something like this. So this would be larger, let's say 60 degrees. So as we go further away from the window, we need to reduce the field of view, and as we get closer, we need to increase the field of view. So to calculate that, how large is this window? We can measure it in an orthographic view. Is this, yeah, that the portal? Okay, that's the portal. So using the middle mouse button and dragging a line, you can see the distance. Yeah, it's 200. See, it's 200. Okay, so let's go back to perspective view. Now let's do the update in field of view part also inside here. Set field of view. So how do we do that? We need to know the distance. Capture component PC. So we need to know the distance from the window. So actually, if we just get the relative location of the capture component, get relative why can't I access that? relative location. Okay, well, I should be able to use that like this, right? And then get vector length. So this will give us this this distance from the center to the camera. And then we know the height, so we need to divide. Now this, divide 200 from this distance. 200 from this distance. 200 means this size. This size is 200. So, and then, so in case we get a 0 here, we might run into problems. So I'll make the 1 as the minimum value we can get from this calculation, right? And then we can get a tan or tan inverse of this value. So this will give us this this angle. So this also I clamp in between, let's say 5 and 180. Okay, now let's see. Let's see. Now we don't see anything underneath. It looks correct. Yeah, like we might see from a location like this. So okay, and even if I move this, the logic will not break, it will work. Let me move it a little bit here. See, it still works. If I check from here, we should see those blue boxes now. See, right? So yeah, that's how we let me move this up a little bit. That looks better. Okay, so that's the first part of the portal. Now this jumping through the portals and also shooting at walls with the portal gun and placing the portals in the places we need, dynamically changing them. Those parts I will work on in upcoming episodes. And I'm gonna stop this episode right here. So thanks for watching. Updated project files will be available for the download in Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of Patreon Club. See you in another episode. Goodbye.